Welcome. This is Steve French. I'm a principal software engineer with Microsoft Azure Storage. I'm also a member of the Samba team. So I'll be talking today about accessing files from the smallest to the largest over the most popular files protocol, SMB3.1.1. So I'll be talking about the Linux client and also something about the Linux server, the new kernel server. I'll be giving, to start though, I want to give an overview of the Linux file system activity generally, because it's interesting to many people in the storage world what's going on in the Linux specific storage world. Then I'll be talking about the kernel server and its recent improvements, and then I'll talk about my favorite topic, the client improvements, both the kernel and utilities, and then what to look forward to that's coming soon. And then, of course, what's most important of all is probably improving quality, reducing the probability of regressions, improving testing, and I'll talk about that a little bit at the end. So as you guys probably know, Linux has a habit of having interesting names for releases. A year ago, we had the 5.13 RC2 release, which perhaps appropriately was called Frozen Wasteland. And, you know, I think to many of us it felt that way with lockdowns and difficulties getting to in-person events, but hopefully this next year we'll be able to be in person here. Next week, we expect the 5.19 RC1 kernel to be released. Linus created the name Superb Owl, probably a pun on a sporting event you guys may have heard of. But I kind of like the Superb Owl because I'm a Rice University graduate, and the mascot of Rice is owls, and they think of themselves as sort of unconventional wisdom. So a Superb Owl seemed to kind of fit with what I think of when I think of my university. But I think he was referring to a certain sporting event with the name for 5.19. Okay, a few weeks ago, we had the first in-person Linux developer event, kernel developer event, the LSF, the Linux Storage File System and Memory Management Summit. But now that includes eBPF, the tracing facility that's kind of the way forward for dynamic tracing in Linux. So as you can see from this picture, I'm in the bottom left here. We have an opportunity to get all of the developers together in person, and there was also a few virtual as well. But the amount of progress made was fantastic. And I want to go through a few of the things that were discussed because they may be relevant to this broader storage audience. By the way, you may recognize many well-known developers in this picture, some very interesting people. So some of the things that were talked about in LSF that may be of interest to you include the complete redesign of the page cache for Linux, support for larger size pages, not just 4K pages, folios, the redesigned FS cache, the offline cache, but also the in-memory cache, page cache. And then Dave Howells has been working with Matthew Wilcox and others on kind of mapping libraries, layers to make it easier for network file systems to plug into this newly designed page cache that's called NetFS. Amir talked about StatX and FSInfo, as well as some of the iNotify, FA-Notify, and so did I. I talked about things that we could use to extend StatX to support, let's say, reporting offline files, reporting files that have extra integrity checks. I also talked about the kind of irony that iNotify was added for network file systems, but it doesn't support network file systems. It supports only the servers because iNotify and FA-Notify are not passed down to the file system. They're handled in the VFS layer. So one of the things that we've talked about changing is being able to support it over the wire. Today, if you want to wait on a notify event for Linux, you have for, let's say, SMB, you have to call a private iOctal for this. The standard notify API only works locally. Christian Brunner talked a lot about ID map mounts, very useful for containers. The NFS developers, especially Chuck Lever, talked about in-kernel encryption with TLS. TLS is partially implemented in kernel, but how to do the handshake for an NFS. Now, for our SMB world, this is less interesting because SMB supports very strong encryption already. But if we want an alternative, Windows supports Quick, which was reported on at the last few storage conferences. So using Quick, as HTTP3 does, is a kind of a better alternative than TLS. So we have there are interesting discussions about how to put this in the kernel, and also, of course, IOU ring. IOU ring is the way forward. You know, we've moved away from AIO in Linux toward IOU ring, and it's being extended even for non-file-based operations. Fantastic stuff. Matthew Wilcox and others have worked on. I strongly recommend looking at LWN, the Linux Weekly News. It has articles on many of these things. It covered 3 of the talks I gave, but also these talks and many others from the recent events. And that gives you an idea of sort of where we're going in the file system world. But stepping back a little bit, the biggest thing we have to deal with is we have to deal with this insane difference in scale from slow things in the cloud with long latency to fast things in the cloud with very low latency. We have to be able to support NVMe and fabrics and underneath, and changing the performance profile completely. And of course, over the network, we have RDMA, SMB direct, not just your traditional network adapters. So we have to be able to support orders of magnitude different performance in network, disk, and CPU. And that creates interesting problems for file systems. So let's give a quick review of what happened this last year in the Linux file system world, since you know, a year ago was 5.13 RC2. So about almost 7% of the kernel change sets were file system related, because it's one of the most watched parts of the kernel. File system activity was slightly up from a few years ago. Linux kernel file systems are a little over 1 million lines of code, which sounds big until you compare it with a project like Samba. It's not even a third the size of Samba, all the file systems put together. But you know, for kernel code, this is pretty big, and it's carefully watched. Now, what are the most active file systems? I think many of you guys can guess this: BTRFS and XFS. But number 3 and 4 are the 2 network file systems, NFS and SMB. NFS activity has increased. It had slowed down a few years ago, but now it's both that NFS and SMB kind of way outnumber, you know, the other remote file system choices. You know, they even get more change sets than the ext4. But we also have a kernel server, ksmbd. And as you can see, even though it only was added in the 5.15 kernel, it already has more activity than NFS server. So it's kind of a neat, it's a neat time to be in the SMB world, with lots of SMB client activity and a new kernel server, and also Samba, which is incredibly huge and interesting project. So one of the things I found fascinating was that even though NFS and SMB had similar number of change sets, that cifs had almost twice as many lines changed. Some of this is restructuring probably of you know, common code between the kernel server and kernel client, but a lot of this is just we're making some big, cool changes. Cifs is now 60,000 lines of kernel code. You know, it's 2% larger, but it's been adding some really cool features, and that doesn't count the user space utilities. One thing that's interesting about ksmbd, even though it's smaller, remember that we made the decision to remove landman code, NTLM v1, we removed SMB1 code. So intentionally, it was a lot of legacy code was removed. And so that's one reason why it's able to be so much smaller, you know, 10 times smaller than the equivalent piece of Samba. And of course, it also has fewer features, but those are growing. I think what's fascinating about this is it's a very easy, you know, wrapping your head around 25,000 lines of code is quite doable. And it's a fascinating project. Samba server, obviously many orders of magnitude bigger and much more active. So hopefully we'll be able to do in-person Plugfest soon. I think one of the things I've loved about SMB is that, you know, 4 or 5 times a year we've been able to have Plug, or 6 times a year sometimes, but you know, at least 3 or 4 we've been able to have Plugfest until the lockdowns a couple of years ago. So hopefully we'll be able to resume Plugfest like this at some point. But in the meantime, I want to remind you guys there's a virtual SMB3.1.1 Plugfest this week, so you're welcome to attend that, and we look forward to testing with you, because there's such a wide variety of SMB servers and clients embedded devices, implementations. It's fascinating. User space, kernel, lots of OS. So let's talk a little bit about what are the goals of SMB. This repeats an earlier slide you may have seen before, but I think it's useful to repeat. What we want is the fastest, most secure, general purpose way to access file data, whether that's in the cloud or on premises, whether it's virtualized. We want to implement all the reasonable Linux or POSIX features. Linux goes way beyond POSIX, 3 or 4 times the number of syscalls. But these Linux features, many of them are only supported in local file systems. Well, we don't really want apps to have to special exceptions for local versus remote code. We'd rather have them not even know most of the time they're running on a network mount. We'd like them just to run similar to local. So I think it's important to remember that as Linux evolves, that we need to be able to add features quickly, not wait 6 or 7 years for an RFC. We need to be able to quickly add them to Linux kernel client and Samba and ksmbd to evolve the protocol. The protocol is very extensible: negotiate context, open context, reconnect context, lots of info levels, and it's a very easy protocol to extend. But you can imagine new FSCTLs or new flags that could be helpful for as Linux continues to evolve. So Namjay provided me some slides talking about the Linux kernel server progress. So I was going to start with those and then move on to my favorite topic, the client. So giving an update on ksmbd first. So it was merged into the 5.15 RC1 merge window. It got reviews for about 5 months before it went into Linux Next, and then sat in Linux Next for many months as various people reviewed it. To make Ned happy and also to make the module and directory names more consistent, we changed the source directory from cifs.ko to ksmbd, and we also called the kernel, the daemon that runs the background, ksmbd instead of smbd. Samba calls its processes SMBD, so ksmbd kernel SMB daemon. It makes it easier to distinguish those processes from one another in case you had the kernel client and server running at the same time. We're going to eventually rename the CIFS source directory to SMBFS client, but currently, at least we have an SMBFS common directory that's shared between the server and client that we're moving more and more code to make it easier to maintain. But we do want to sort of avoid using the word CIFS where we can and try to move to SMB3. For example, you can mount today in Linux SMB3, mount-t SMB3. And we'd like people to think about that, and going forward is to, when you mount SMB3, for example, it won't even let you specify SMB1 version, verse equals 1 or cifs. So it's kind of neat. Even as we go forward, we may be able to have people turning off SMB1 code more and more. Unfortunately, there are certain workloads where people require it because of very old servers. But given all the political situation today and the cyber attacks, it's good to get rid of less secure 25-year-old use cases and focus on the highly secure SMB3.1.1. So one of the things that was great was one of the first things Namjay and his team added was ksmbd's support for AES 256 encryption. SMB already supports CCM and GCM, and AES 128 GCM is offloaded to the hardware, so it's very fast. You can see some examples of the benefits of the hardware offload here. But the AES 256 GCM is sort of the military grade that's the strongest encryption possible. AES 128 is perfectly adequate. It's not an issue at all, but some government accounts required AES 256, and Windows supports that, and so does Azure and ksmbd. So you get the benefits with GCM of hardware offload, and you get very, very, very strong encryption whether you're using AES 128 or 256. So it was neat to see that added. Kerberos support, strong authentication, is handled via upcalls to the ksmbd mount daemon, uses libkrb5. It supports duplicate extents, which is used for things like reflink. It's helpful for things like for various fallocate operations like insert and collapse range. And it helps us pass many, many more XFS tests by supporting these operations. One of the nice things about ksmbd is it doesn't have to deal with VFS mappings like Samba would for plugin modules for BTRFS and XFS and that sort of thing. ksmbd just is able to directly go, since it's in the kernel, directly go to some of these file system calls without requiring a mapping layer. Multi-channel. So one of the really cool features about SMB is its ability to dynamically add and remove channels and basically leverage multiple network adapters at one time, or even in the case of one adapter, you get performance benefits from having two connections open on the same adapter. And multi-channel greatly improves performance. It's a great feature, but not all servers supported. Windows does, obviously, Azure does, and of course, ksmbd. And the Linux client supports it, but not as well as the Windows client. The Linux client, we had some reconnect fixes that have been going in over the last 2 or 3 releases that have improved the stability of it. And it does have good performance, and we test it regularly. But the one feature that I'm literally just reviewing right now is the ability for the Linux kernel client to query interfaces dynamically. So as a network adapter changes its address or is taken down, we auto detect that and either remove it or reconnect to the new address. This is a very, very useful feature of multi-channel, but it's great to see ksmbd servers supporting it because it's a great performance feature. Here's an example of a Wireshark trace. You can see the query network interfaces call returning the multiple adapters. You can see the client binding to those adapters, and then here you can see the different colors. The write requests send on different interfaces. They're interleaving the write requests on both channels. So one of them, 192.168.0.3 and also 0.4, 2 different network adapters, and the writes are interleaved across those 2 channels. So SMB Direct is working, and direct releases, change notify. So these are cool stuff. So here's a little bit more recent update. A lot of the focus in the last month or 2 has been on RDMA for numb and team, being able to support multi-descriptors in SMB Direct. RDMA performance is particularly exciting because it reduces the CPU cost, increases the bandwidth, and lowers latency. But one of the problems we have is how do we test this regularly, because not everybody has RDMA hardware. So one of the things that's been nice is that recent changes that allow working with soft iWarp and soft Rocky mean that you can now test with RDMA emulation, not just with real hardware. And it's great that Windows can auto-detect the RDMA without having to do any configuration. You just plug in the adapter and Windows automatically figures it out. And soon Linux will automatically figure it out, although today you can do that with mount options. So here's some performance tests, and here's a description of his performance test setup. So here's comparison between single and multi-descriptor, and you can see the write and read speed improvements. Here you can see some write performance numbers as you increase the number of RDMA connections, and also you can see the benefits of using the larger I/O size. We typically see 1 meg or 4 meg I/O to most servers not using RDMA. NFS, typically you see 1 meg max, but with SMB, you either see 1 meg or to Windows 4 meg and to Samba 4 meg. But with RDMA, with SMB Direct, you can go up to 16 meg, and you can see the slight performance advantages from that. So it's kind of a cool thing. Here's the read performance using a larger I/O, 8 or 16 meg. Now, if you're interested in contributing to the kernel server, there are lots of cool features to work on. One of the things that was brought up in Samba XP recently was improving the integration with Samba by leveraging their new RPC architecture. So they now have separate processes to handle the RPC calls, and it would be possible for ksmbd to support ancillary protocols like the witness protocol by tying into existing Samba code for that through that RPC daemon. So that's one of the things that was discussed. This family of protocols for SMB3.1.1 is huge. There are lots of really cool features. Now, talking about roles, Namjay is the maintainer, and he gets help from Sergey and many others. But I also co-maintain, and what my role is that the Git merges go through my tree to git.samba.org do a git tree in git.samba.org for ksmbd, and I ensure that additional functional testing is run and I check these patches. But my focus is largely on the client side. But of course, Namjay would love additional help with code reviews, auditing, testing, new features. This is an extremely exciting time. And also the Samba team, they're starting work on the POSIX extensions now and extending directory releases. It's a great time to contribute to server code as well. So let's talk about the client code, my favorite. So as we talked about with the server, SMB3.1.1 security is fantastic. It even added support for AES GCM 256. So we negotiated AES GCM 256, the sort of strongest military grade encryption by default if the server requires it. Azure, Windows, ksmbd supported now and can be configured to require it. But the client can also force using the strongest encryption instead of using the very strong GCM 128 to use the strongest GCM 256. Just requires setting this module parameter, going into the sys module parameters and setting it, or when you insert the module, setting this required GCM 256 parameter. You'll be able to force us to use the strongest encryption on the client side, and similarly on the server, it can be configured in the server config to require the strongest encryption. And here's an example of the Linux client mounting to Windows with required GCM 256 set. You're getting the strongest encryption. You can see the last frame here is the first encrypted frame, the tree connect. So what about performance improvements? I'll give a couple examples that I think were super exciting. Performance rocks. It's been so exciting to see the changes. But let's take a super simple example. I'm going to download a file, a 10 gig file. And it's going to be just from Azure XSMB server down to a local client VM, not even a very fast VM. The old defaults, even with SMB3, everything's encrypted when you're in Azure, so it's using SMB encryption, but SMB3 only supported the slower CCM encryption. You see you get 143 meg per second downloading that. Well, what if we used SMB3.1.1? With SMB3.1.1, we're going to negotiate GCM 128. Goes hardware offload, it's faster encryption and decryption. Notice it's 41% faster. Well, what if we took advantage of the things we were talking about with multi-channel, but also set this new mount parameter RA size, which allows you to request from the page cache that you request more IO than your read size. Normally, the page cache will only read one thing at a time. So when it's reading ahead, it's only going to have one request in flight, which means the parallelism is kind of messed up. There's long latencies. Ideally, you want 3 or 4 requests in flight. And so by setting RA size to 4 times, so in this case, we have R size set to 1 meg, RA size set to 4 meg, so we could have as many as 4 requests in flight. That means we don't have the dead time on the network. But what's nice about that with 2 channels, even something as simple as 2 channels, which is what's recommended in many network configurations, even for Windows, we're now more than 3 times faster than, so we've increased performance more than 3-fold. So lots of great performance improvements. And that's just a simple example of a file copy downloading. So here's another example. So I think many of you have seen benchmarks that, open a file, create the temp file by writing some data to it, close it, and then start the benchmark to read it. Well, in a network file system, if it's able to use handle leases or deferred close, that's basically a no-op. Because after you've written the temp file, the reading it doesn't cost anything. It's already cached. So what we do with handle leases are hold off sending the close across the wire unless the server requests it because another client's opening it. So we can hold on to the file open for a few seconds. So here's a simple example. We create a random file called 2G, and then we read it. And before, the 2 gig copy was getting 3.7, but with this, we're getting more than 3 times faster, almost 4 times faster. What if you read the same file twice? Reading the same file twice, way faster, 3 times faster, because we already have it cached. So one of the things that's fascinating about these handle leases, there's so many common examples where this provides performance benefit. And thanks to Rohit's work, we now support that. So use cases where you open a file, close a file, open a file, write to a file, close a file, then open and read it. We're going to be so much faster now. So here's a little more detailed dive into the performance features and how they look. The 5.13 kernel got a big boost. We talked about the RA size example. Ronnie did some good work. Ronnie at Red Hat did some good work on fcollapse and finsert, emulating those with the duplicate extents call we talked about earlier. Rohit added support for deferred close, greatly improving the performance of some workloads. Also, Ronnie improved directory caching of the root directory. We talked about the support for GCM 256, but we also added support for shutdown IACL, which can be helpful for emergency situations where you want to do emergency unmounts. Also, there's various XFS tests that use shutdown IACL. And then we did the error handling improvements to the mount API. As you probably know, the mount API was completely rewritten by Dave Howells a year or so ago. And this makes it easier with, now that SMB has been modified to go to the new mount API. It makes it easier to do things like remounting, but it also makes mount error handling better. So in the 5.14 kernel, we can now allocate smaller ranges up to 1 meg, thanks to Ronnie. Paolo Sousa did some great work on DFS reconnect improvements. There are so many corner cases of reconnect and reconnect retries. Just recently, just checked in some changes from Shyam on some multi-channel corner cases for reconnect. I started work on being able to negotiate to parse the signing context, to be able to negotiate which signing algorithm, because as you can imagine right now, it's actually faster to encrypt than it is to sign a packet, because in encryption, you get the benefit of hardware offload, where with signing you don't. Well, with newer Windows servers, they support this negotiate signing context, which would allow us to get fast performance even for just packet signing, which you would expect to have been faster. So support for this is partially implemented. We're maybe a third of the way through. And I think very exciting was we were able to remove, just as I mentioned, the kernel server doesn't include this, being able to remove the weak authentication algorithms, NTLM v1 and LANman was great. I think with all the cyber attacks you've seen in the news over the last 6 months, or the last few years, actually, there isn't a strong case to leave NTLM v1 or LANman around anymore. And also in 5.15, we merged the kernel server. So in 5.16, there were some performance improvements for compounding, multi-channel improvements, and more work on FS cache, the Dave Howells rewrite of the offline caching infrastructure. But I also added a new mount farm TCP no delay. We were investigating some problems where it appeared that the network stack, despite our configuration, was still hanging on to packets longer than we expected. It shouldn't have been, but we were debugging some of these problems and thought it might be easier to allow explicitly forcing TCP no delay. It shouldn't be necessary the way we have our sockets configured, but you don't want buffering latencies on the client. You want to send the packet out the minute we write the full SMB. Okay, 5.17 kernel, the new FS cache mechanism was rewritten. We also, at the request of some server guys, wanted more debugging information. I think Windows sends the OS and build version across the wire during NTLM SSP negotiate, which makes it easier to kind of diagnose server problems and client problems, customer problems, because you have a little bit more information about whether that's got a client with a known bug. Because obviously one of the problems you have as a server developer is that so many of the problems were fixed years ago, but the customer may be running very old, RHEL 7 or CentOS 7, or maybe they're running an old version of Ubuntu 16 or something. Anyway, the 5.17 kernel had some important DFS and ACL fixes as well. Fast forward to 5.18, Ronnie did an interesting change where there were cases where we were compounding, which was good for stat or statfs, not doing open query close or open query file system close. But there were cases where we didn't even need to do the open because we had a cached root file handle, for example. We had a customer example where there was a kind of storm of querying the disk space available. And we could cut all the opens and closes by simply reusing the cached file handle for the root. So we made sure that in our compounding code paths that we at least check to see if there's already an existing handle open for that. And one of the really exciting features in 5.18, which I think many of you didn't realize, wasn't actually a change in my code, it was a change in the Linux VFS. It helps BTRFS and it helps SMB a lot. But it's a cross-mount ref link. So if you're mounted to Windows REFS, or if you're mounted to Samba running on BTRFS, or I don't know, ksmbd mounted to XFS, there's various file systems that support ref link, duplicate extents. And in the past, the VFS would forbid doing copy offload between two mounts. So if you were dragging it from share 1 to share 2, maybe your mounted share 1 is mount 1 and share 2 is mount 2, you weren't allowed to do the copy offload, the ref link between them. But they removed that because BTRFS and SMB have cases where you're mounted to the same server, and or you have a subvolume on the same thing in the BTRFS example. And what this means from our perspective is you have cases where you may have 2 mount points to the same server, and now you can get 1,000 times faster copy between these two shares because the server side can do the copy. In the past on Linux, this required that they be on the same share and same mount, excuse me. So, you could get the server side copy for copying within the same mount, but now you can get it even across mounts if they're mounted to the same server. So that, increasing copy performance by 1,000 times is pretty cool. So I'm very excited about that. And I think it also helps BTRFS as well. So the merge window should close in a few days. Linus just took a few hours ago the changes that I sent him for the kernel server. And a few days before that, he took the client changes. There's some important performance optimizations. One exciting one from Ronnie is we now better cache the whole contents of the root directory. So when you do an LS of the root directory, we're going to be able to keep those contents because we have a directory lease on the root directory. And so for servers that support directory leases, we're able to keep the contents, not just the, historically, it's great to have a handle for the root directory, and it's great not to have to do a revalidate to make sure the root hasn't been deleted. It's great to do a revalidate to avoid the number of metadata calls across the network. But what we can do now with the 5.19 RC kernel is we can cache the whole contents of the root directory. And one of the things we're going to be doing in the future is extending this across subdirectories as well. So we can cache subdirectory contents as well. There were some very important multi-channel reconnect improvements from Shyam Prasad, and then some RDMA improvements. So one of the things I find particularly important to mention is the tracing is so important, dynamic tracing, eBPF. And if you guys don't know about eBPF, look it up now, it's fantastic. But dynamic tracing is something that a lot of the major companies are contributing to now. From my perspective, I just try to add dynamic trace points, and we added 10 more this year. And I really want feedback from you guys if you have additional dynamic trace points you want, like you're trying to debug a problem or looking at a performance issue or trying to understand something. Dynamic trace points are very cheap to add, and they don't have any performance cost unless they're turned on. And as you can see, we have 96 of them now, and they allow you to analyze specific things like when you're low on credits, or when you have errors on write, or when you have errors on read, or I think some other examples here are that might be interesting are when you have a reconnect or a network failure. You can look at the different types of causes for reconnect. But in any case, dynamic tracing eBPF matters a lot. If you want to learn more, Brendan Gregg has a website about this, and there's fantastic information. LWN has some good articles as well. There are some good examples in the Linux cifs troubleshooting page, but it can be as simple as just typing trace cmd record cifs and then trace cmd show. So if you have additional trace points, please let us know. Also, remember, we have other debugging things like procfs cifs debug data, but also we can show which files are open. You can use LSOF, of course, but you can also look at procfs cifs open files, get information about that and correlate with server logs. And also remember that we have the ability to not just look at the number of IOs, and number of bytes read and written, and the different types of network requests, so you can understand what your app is really doing, whether it's a metadata or data heavy app, how many errors there were, or how many reconnects. But you can also look at latencies if stats2 is enabled. So in cifs utils, there was a major security fix done fairly recently in April. And then in the 6.14 release, added support for being able to view alternate data streams from the SMB info tool, also being able to dump keys from the SMB info tool, which can help when you're trying to look at a Wireshark trace when it's encrypted, but also set cifs.ko improvements. More recently, since 6.15 came out, one of the features added to the user space utilities was the support for GSS proxy, which improves the KRB5 credential retrieval. So if you can't find your KRB5 ticket and you need to, you're at mountain time, you're trying to locate the ticket that the user got to be logged on to Kerberos, GSS proxy is a service that can be useful for that sometimes. And this integrates, adds support for integrating with that. Now, coming soon, I think you can expect to see in the next few releases, extending the use of directory releases to greatly improve metadata caching. It's currently limited to the contents of the root directory. I got partway through adding compression support. I probably have a quarter of the way or third of the way through. Windows has a parameter on mount allowing you to compress network traffic for that mount and that use. That compression context we partially support now. Like I said, we're about I don't know, quarter of the way through maybe. Also, the discussion I had, LWN has a little article about that, about how statx, xstat, the Linux query attributes call, could return additional SMB3.1.1 attributes like offline, perhaps, so you can recognize in your application more easily without having to call a special ioctl. You can recognize more easily that the file is offline. Also, these improvements we talked about for FA notify, iNotify, without having to use a specific SMB ioctl like you do today, being able to use the generic Linux FA notify would expose this very common server feature to the Linux world much more broadly. And I'm particularly excited about SMB3.1.1 over Quick. There are multiple alternatives that have been discussed about, could be used for porting it in the kernel code, but if we port it into a common library for the SMB protocols first, and then as it stabilizes, we move it into the network tree. This is very powerful because Windows today supports SMB3.1.1 over Quick, has it in the Windows kernel, but today Quick is only in user space for Linux. And it's very exciting because it solves many performance problems, not just the port 445 problem and giving you an alternative for encryption. And I think we mentioned that there's lots of work going on with Dave Howells and Jeff Layton and especially Matthew Wilcox on the redesign of the page cache. But Dave Howells' work with NetFS can provide a lot of benefits for us as we integrate with this new page cache mechanism. And last but not least, we really need to test the POSIX extensions more and more and more and consider extending it. Soon Samba will be, right now there's a fork of Samba that implements it, but mainline Samba, there's some work starting on that. But it's implemented in the kernel server. And there's also user space client you can use, but what I'm particularly interested in is testing the POSIX extensions from the Linux kernel client to the Linux kernel server to make sure we're not missing anything. So testing, it matters a lot, and I wanted to remind people about that. The build bot is fantastic. We test various different target server types from Windows, Azure multi-channel, Samba, and ksmbd, and we'd love to add more. So if you have a particular product you'd like us to test against and it has virtual machine we can create in Azure, let's go for it. So we also have a general cifs testing one that tests various configurations and various server targets, and we keep adding tests for these. We added 21 additional XFS tests. XFS is the standard functional test group for Linux file systems, local or remote. And we now are up to 245 tests we run on every check-in. Standard file system functional tests run on every check-in to Linux. Everything is into Linux. Multi-channel, we added 25% more tests last year. We're now up to 133 just for Azure multi-channel, and we do 144 to ksmbd, and we keep adding them. There are detailed wiki pages on wiki.samba.org and setting this up and which tests run and how to enable more tests. But it's an exciting time because testing matters and quality matters, and we want to reduce regressions. But I want to encourage you guys to reach out to us on the Linux cifs mailing list and provide us patches and feedback, and we'd love to continue to optimize the SMB client for a wide variety of workloads, a wide variety of use cases. Anyway, thank you for your time and look forward to hearing from you guys. Thank you. And here's some additional resources that may be helpful.